We spent the majority of this unit talking about light, EMR, as a wave. It was pretty well established prior to the 20th century that EMR was in fact a wave. There was lots of evidence to support that. There was diffraction, interference, refraction, polarization. But then in 1905, Einstein said that this wave, this EMR wave, is a particle. It has a duality associated with it, a wave-particle duality. Sometimes it behaves like a wave, and sometimes it behaves like a particle. A few years later, a guy named Louis de Broglie, a French guy, makes a symmetry argument. Physics is a very symmetrical subject. When A causes B, then B will often cause A. Electricity can cause magnetism, right? Magnetism can cause electricity. De Broglie suggested that if an EMR wave can be a particle, then why can't a particle, like an electron, be a wave? So he developed a hypothesis based on that symmetry, that particles, small particles like electrons and other subatomic particles, do in fact have a wave nature. This wave nature can be expressed mathematically using an equation, he said. He derived an equation. We're not going to learn that equation, but there is an equation that he used to describe the wavelength of a particle, the wavelength of an electron. Having said that, at this point there was still no evidence to support that. His argument was a hypothesis. It was based on symmetry. It made sense, but there was no proof. Where does the proof come from? We now do have proof. Okay, de Broglie was correct. Electrons do have a wave nature. Just like EMR is a wave and a particle, electrons and other subatomic particles are particles and waves. Where does the evidence come from? Well, look at this. If you have EMR or light shining through these two openings, that EMR will diffract and interfere and produce a pattern, an interference pattern on the screen on the other side. That's nothing new. That's Young's double slit experiment. We spent a couple of days talking about that earlier on in this unit. Okay, interference pattern shows the wave nature of EMR, the wave nature of light. But watch what happens if I change things up a little bit. Let's say I use baseballs. The openings are wider, of course. Let's say the openings are the size of a doorway. If I fire one baseball at a time, I throw one baseball randomly at a time, the ones that make it through the openings will go through one opening or the other. And they will cause, on this screen over here, on the far side, a dent, either here or here. If I throw one at a time through, I throw 1,000 of them through one at a time, eventually you're going to see a dent pattern in this screen on the other side that looks like this. Agree? Two dents. Two doors, two dents. If I change this, though, to an electron, which is also a particle, just a much less massive particle, we should expect to see something similar as we did with the baseballs, right? Fire an electron through narrower openings, one at a time, and we should be able to detect two spots where they struck. We're not going to dent the screen like baseballs did, but we should be able to detect two spots where the electron struck. But here's the crazy thing. When we fire electrons through these two openings, one at a time, it doesn't produce the baseball pattern, but rather it produces the EMR interference pattern. One electron goes through at a time. It produces a spot. Another electron goes through. It produces another spot, and so on and so on and so on. Over time, this is the pattern that we end up seeing. The only reasonable explanation from this is that the electron behaves like a wave. If EMR is a wave and it shows this interference pattern, and electrons also show the same interference pattern, then an electron must be a wave as well. In fact, what's happening here is a single electron. This is kind of wacky, but a single electron goes through both openings at the same time as a wave, interferes with itself, and then ends up producing an interference pattern on the far side. So de Broglie hypothesized that things like electrons should have a wave nature in addition to their particle nature, but the evidence didn't come till later on. It came through electron diffraction experiments.